Hi everyone, welcome back to Graph Theory Visualized. In this chapter, we'll be looking at a specific class of graphs, known as regular graphs. Specifically, we'll be looking at a subclass known as irregular graphs. What makes regular graphs special is that they refer to graphs having vertices of the same degree. For irregular graphs, the maximum degree of the graph is equal to the minimum degree of the graph. The R in our regular graph refers to the degree of every vertex in the graph. Recall the previous inequality for the bounds of a degree of a vertex. It applies for R. Notice that we didn't specify the number of vertices that there are in an R-regular graph, just the degrees of the vertices. But there are restrictions on how many vertices we can have in an R-regular graph. Notably, no graph can contain an odd number of odd-degreed vertices. This comes as a corollary of the first theorem of graph theory. Here are some examples of R-regular graphs with different orders. We have seen these graphs before. They fall into the class of graphs known as three-regular graphs, or cubic graphs. Some famous examples of cubic graphs are the Peterson graph and the complete bipartite graph of 3, 3. You can clearly see why these are three-regular graphs, as all vertices have degree of 3. The maximum degree of the graph and the minimum degree of the graph is equal to 3. I hope this gave a solid introduction to regular graphs, and what happens when we restrict the number of degrees in a graph. I find that they can lead to some fun problems and interesting shapes of graphs. In the next chapter, we will extend the definition of vertex degrees to explain the whole graph. We will look into the topic of degree sequences. Till next time.